Oh, welcome and thank you for joining. Let's take a look at another example where we use analytic geometry to prove properties of geometric shapes. This time we're looking at example number 3, where we're given that triangle DEF has the vertices given at 4, 2, negative 6, 4, and negative 2, negative 4. Now, AB, that should be a line segment, right bisects EF, so EF at some points S, and GH right bisects DF at T. We have to determine the coordinates of the circumcenter of triangle DEF. So let's stop for a second and focus on the question asked. We're asked to find the circumcenter of the triangle. Now remember that the circumcenter of a triangle is at the intersection of the right bisectors. So intersection of right bisectors. Now, what is a right bisector? Now, just like the name says it, a right means that the bisector, which is a straight line, will intersect the line, the side lengths of the triangle, at the right angle or 90 degrees. And bisector means that the intersection will happen right at the middle of the line segment. So bisector means cut in the middle, or the line that cuts in the middle. That's what a right bisector is. So for short, this is going to be a line that cuts in the middle at the 90-degree angle. Now, we're going to read the problem again, but this time, while we read the question, we also plot the points on the Cartesian plane. So we have the point D with coordinates 4 and 2, which means x is 4, y is 2. And if x equals 4 and y equals 2, then we're going to go at x equals 4, y equals 2, which makes the location of point D be right here. So we're going to mark this point as D, and on the side, please write the coordinates as well. It's always good to have the information on the diagram because, as we have mentioned in the past, we can make the connections between the information given and what we required faster, and this way we can reach to the solution faster. So the next point is point E, where x is negative 6 and y is 4. So x negative 6, y 4 means that the point E is located right here. So again, we're going to mark the point and label the coordinates negative 6 and 4. And lastly, we have point F with x negative 2 and y negative 4. So here's x negative 2, here's y negative 4, which makes the point location be right here. So we're going to make this, I don't know, let's make it color blue. And negative 2 and negative 4 is right here. And that would be our point F. And we're going to write the coordinates as well. Now let's connect these points to see what we have created here. So we have a triangle DEF. Okay, now next we are going to draw AB that right bisects EF at S. So we're drawing a line segment AB that cuts EF at the middle perpendicularly. So here is EF, all right? And let's say this is the middle of it. And now the middle of it would be the point S. So we're going to write here, and I'm assuming it's somewhere in here. And that would be S, but again, we're going to have to find the coordinates. And right at this point, we're going to drop a perpendicular. This looks like a perpendicular. It doesn't really matter how long a segment we draw, as long as we label it correctly here, A to B. So next, we are going to draw the right bisector GH, which right bisects DF. Okay, so here is DF. Say this is the middle of DF, and the middle of TF is marked as point T. Now at point T, we're drawing a perpendicular to it, and as you can see, this is a 90 degree, this is also 90 degree, and we see here, or we notice, I'm going to actually try to change this a little bit. okay? So we're going to label this as GH. So this is G and this is H. As you can see, they intersect at some point in here. Now remember that this is not to scale yet because we're just drawing this approximately, so we're estimating it. But what's important to remember is that every triangle will have 3 right bisectors, so 1 for each side. Now the 3 right bisectors always intersect at the same point. So this point is what we call circumcenter. Now, if we want to find the circumcenter, we can find it as a point of intersection of any 2 right bisectors, which means we do not need to draw the 3rd right bisector. We just know that this is going to fall, or it's going to pass through the same point right here. Now, we are going to get started and try to think. If I want to know or to find the coordinates of this point of intersection of the right bisectors, that I am going to mark it in color purple. And I'm going to call this actually the point, let's call it M or S. I'm sorry, C. C is a better word because, this is also called the centroid of the triangle. So if we want to find the coordinate of point C, then we have to think, well, what is point C in this diagram? What does it represent? So where is it located first? So point C is located on this line segment, and it's also located on this line segment here. So it's located in both line segments. So we're going to say that if I want to know the coordinates of point C, then I can find it as the point of intersection of these 2 line segments. But to find the point of intersection, I'm going to need the equation of each line. So now my solution has become, or my first step has become clearer. I'm going to start off by finding the equation of AB and then finding the equation of GH. So I'm going to make room for it, and organizing the information is very important in any math problem, but especially in geometry. So we're going to write here the AB equation, and we're going to write here the GH equation. Now, equations are easier to find when in y equals mx plus b form. So y equals mx plus b. And we are going to search for basically the slope and the y-intercept in each of them. So we're going to do this one at a time, but remember, the way we do AB, we're going to do GH as well. So if you understand how we do AB, stop the video and continue finding GH on your own. Now, to find the slope, we have to think, where is AB located? So it's perpendicular to this line. So for AB, I don't know the coordinates of any 2 points to find the slope. So I do, or I can find the coordinates of the midpoint, but I don't know exactly what the coordinates of another point on the line would be, right? So I have to think, okay, so how would the slope of AB be related to the slope of EF since these 2 are perpendicular? So we're going to say that to find the slope of AB, we're going to need to find the negative reciprocal of the slope of EF. So we're going to search for EF now. And we're going to say that the slope of EF is going to be the y at F minus y at E divided by x at F minus x at E. So that would be equal to, so let's take a look. We have the y at F 4, the y at F negative 4, the y at E 4. Now the order doesn't matter as we've mentioned. So we're going to go negative 4, subtract 4. For the x coordinate, negative 2, subtract negative 6. So it's important that we follow the correct order. So everything else would be all right if we make sure that they are aligned, right? So, and then we have negative 2 minus negative 6. So that would be negative 8, the numerator. Denominator, as you can see here, we have 2 minuses. That will make a plus. So negative 2 plus 6 is equal to positive 4. So that will make the slope negative 2. So therefore, we're going to say that the slope of AB would be equal to negative 1 over negative 2, which means that the slope of AB is equal to 1/2. Now, next, to find the equation of a line, we're going to need to know the coordinates of the value of y-intercept. And if the value of the y-intercept is not given, then we have to think, what other numbers are we given in this equation? So we're going to think, well, if I had x, now that I have slope, if I had x and y, then I can find the value of b. Now, think about it. Is there any point on this line segment that we have? So in the ready-to-use form, we probably are not given the exact coordinates of any point, but we do know that the point S that is on this line segment is in the middle of EF because it's where the right bisector would intersect, right? So these two sides are equal in length. So to find the coordinates of point S, we're going to use the midpoint formula for E and F. So I'm going to keep the diagram here on the screen. So we're going to say that the coordinates of point S, which I'm going to mark as XS, YS, is equal to, or are equal to, for x, we're going to find the average of the x coordinates of the endpoints on -6 plus -2 divided by 2. And then for the y coordinate, we find the average of the y's, 4 plus -4 divided by 2. So it seems that we have -8 divided by 2, that's -4, and 0 divided by 2, which is 0. So we're going to say that the point S will have the coordinates -4 and 0. So now that we have the coordinates of point S, we can use the equation y equals mx plus b and substitute in it all the values that we know. So now we know the value of y will be 0. So we're going to write 0 for it. The value of the slope is going to be 1/2. So we're going to write 1/2. Multiplied by x. So the value of x is -4. So multiplied by -4 plus 2. So 0 equals -2 plus b. Therefore, the value of b would be equal to +2. So we got the b value, we got the value of the slope as well, and now we can write the equation of the right bisector AB. And we're going to say that the equation is y equals 1 over 2x plus 2. Now, we're going to continue with the next equation, so the right bisector GH, following the exact same process. Now, this time, we are working with this line segment here. We're going to find the slope of it by using the slope of the line perpendicular to it. So we're going to say that the slope of GH is equal to negative reciprocal the slope of DF. So the slope of DF, on the other hand, is equal to y at F minus y at D, x at F minus x at D. So here we go again, y at F minus y at D, so -4 minus 2, divided by x at F minus x at D, so -2 minus 4. So here we end up with -6 divided by -6, which equals 1. Therefore, we're going to say that if the slope of GH, of DF, here we go. I'm going to clarify this. So if the slope of DF is equal to 1, then the slope of GH, so the right bisector, will be negative reciprocal of it. So in other words, simply -1. Now, again, we're going to need a point, and as a point on this right bisector, we are going to use the midpoint T. So we're going to say that the point T, with coordinates x, t, y, t, will be the average of x coordinates, -2 plus 4 divided by 2. And here we have the average of the y coordinates, -4 plus 2 divided by 2. So as you can see here, we get positive 2 over 2, that equals 1, and negative 2 over 2, which equals -1. So these are the coordinates of the point T. Now that we have the coordinates of the point T, then we can substitute into the equation the slope of GH. Okay, and we are going to substitute the coordinates x and y of a point on the line. So again, here goes the slope. Here is the x and the y. So let me just actually mark it with different color. So the x and the y. So now we have y is -1 equals slope. Slope is -1. Now slope is multiplying x. So multiplies x, which is 1, plus b. So -1 equals -1 plus b. Therefore, we're going to say the value of b is 0. So that will make the equation of the second line, or the equation of the right bisector GH, y equals -1x plus 0, or simply y equals -x. So this would be the equation of the right bisector GH. So we got this. And what else we got? We got the equation of AB. And we're going to use the equations of AB and GH to find their point of intersection. So we're going to say that, let me just organize this a little bit. Okay, so this is where we found. All right, so we found the slope of AB, the equation of AB, the equation of GH, and now we're going to find the point of intersection. So for the point of intersection, let's make it purple, which is the point C. We are going to solve the system of equations. So y equals -x and y equals half of x plus 2. So let's put them together. I would use substitution here because it's super easy. We have y already solved for in terms of x, and instead of this y in here, I'm going to put this y in here, which is basically this, and I'm going to write -x equals 1/2 of x plus 2. -x minus half of x equals 2. So we have -1 minus a half. So we can have like -1.5x equals 2, from where x would be 2 divided by -1.5. And 2 divided by -1.5, this is basically like 3 over 2. So when you simplify this, that is going to be like multiplication by 2 over 3, but simply use the calculator. That would be equal to -4 over 3. Now to find the coordinate, the y coordinate, we are going to substitute it into the equation y equals -x, which will make y equal to opposite of -4 over 3, which is basically 4 over 3. And therefore, we're going to say that the circumcenter of this triangle is at the point with coordinates -4 over 3 and +4 over 3. I hope you found the instructions useful. Thank you for learning with me, and bye for now.